Okay, so we're doing the video for section 6.7 and the Math 115 class for LACCD and the ITV program. And in section 6.7, we're exploring relations and functions. Now, when we talk about relations, we're looking at different things mathematically that can be a relation. Okay, so when we're talking about relations, we're talking about a few different ways that we can express relations. We can express relations as a set of points. It'll look something like this. And there will be a set, and there are my points inside. We can also represent relations in the form of a table. We can represent relations, let me put that up a little bit there for you. We can represent relations in the form of a graph, where if you have your x and your y axis here, they could be in the form of points, they could be in the form of a line. So they can look like that. They can also come in, put that up there, they can also come in the form of an equation. You may have like something like y equals 2x plus 1. If you write this and we want to say it's a function, we may use a new notation we'll talk more about later, which is going to be f of x is equal to 2x plus 1, where the f of x is going to take place of the y. And we'll speak more about that a little later in the activity today. So these are all different ways that we can talk about what are called relations in mathematics. The question is going to be, is the relation a function? Now, the law is depending on what type of relationship you're looking at, whether it's going to be a set of points, or it's going to be a table, or a graph, or an equation. There are different ways that you can investigate this and determine if a relation is a function. So as we go through each type of representation of a relation, we're going to examine how we either show or don't show that the relation is a function. And we're going to try to do our best to connect these in a number of ways. So for a set of points, one of the things to think about, so for a set of points, usually we have this indication of x and y being like a point, and I want you to think about the x being like people or a person, and then y will be a place. And you're going to hear me talk about the x being people and y being a place in this first analogy here. So I'm going to go ahead and put that to the side. And let's take a look at this for the first few examples. So first off, in this one it says find the domain and range of the given relation. So let's take a look at this part. So the domain, let me make sure you can see this question here. There we go. So the domain, these are essentially all possible values of x, given the relation that you have. The range are just going to be all possible values of y. Now, this will, we can look at the domain and range of a function or of a relation as well in a multitude of ways. That could be a set of points. It could be a table. It could be a graph. And it also could be an equation. So we're going to explore some of these today. The 4 points we're given, and I'm going to write these vertically, are going to be the points 0, 6, -4, 7, -6, 4, and then 4, negative 6. So these are my 4 points. So if I said that the domain is going to be all the x values, you notice here that we have 4 separate x values. So the domain for the first question, and I'm going to indicate this with set notation as you see they have here, is going to be 0, negative 4, negative 6, and then 4. Now, sometimes they can be, let me put a set notation on that. Sometimes they can be fussy about the order of this in terms of putting this in order from least to greatest. So if you need to be careful of that from MyMathLab, this would be negative 6, negative 4, 0, and then 4. And as I mentioned before, the domain are all the possible x values for that. Let me go ahead and move this up again. For the range, we're going to take a look at all the possible y values then. So for the range, we're going to have 6, 7, 4, negative 6. This time I'm just going to go ahead and write them in order from least to greatest from the get-go. That'll be negative 6, 4, 6, and 7. And in that relation, those are all the possible values of y. And that's how we write a domain. So this would be the domain for this relation here. This would be the range for this relation here, as they showed above. In the next question, they want us now to determine, is the given relation a function? So let's go ahead and take a look at these 4 points. They want us to see if this relation is a function. So what I do is, again, I'm going to write these vertically. And then the next one's going to be negative 8, negative 1. These are going to be the points for question 2. And now what I'm going to do, I'm going to move this up a little bit, make sure that this is in proper view. And then I want to look at the points of question 3. It says here, determine if the given relation is also a function. So I'll do a little comparison between the two questions. All right, so before, what I mentioned that when we have these, and I'll have to just move this up, I'll move it up over here like so everyone can see everything. There we go. That I told you to think about the x values like people, and then the y value like places. So in this case here, notice here that we have 4 different people, and they're in 4 different places. Now, if you had an instance where like all 4 different people were in the same place, that would be okay. I'll show an example of that here in a moment. We have 4 different people in all different places. That's perfectly acceptable. This would be a function. But here, like if 8 is a person, so 8's going to be the same person. We have 1 person in 3 different places at the same time. That is not possible. So because we have the same person in more than one place, this is not a function. Now let me show you an example. One, this is not here, but let's say we had something that looked like this. Instead, I'm going to flip these points around. 5, 8, 2, 8, 4, 8. Using the analogy of people and places, 5, 2, and 4 would be 3 different people. But these 3 different people happen to be in the same place. Can we have 3 different people in the same place? Absolutely. So can we have a person 5 at place 8, person 2 at place 8, and person 4 at place 8? Yes, we can. And because we can, we would say that would be a function. What can you not have? You cannot have the same person in more than one place at the same time. So in question 2, they're asking, would that be a function? The answer is absolutely yes. But for the third one, the answer to this is going to be no. So when you're looking at a set of points, this is the comparison you want to make. And I recommend writing those points in vertical form for the purpose of that comparison, because it's easy to identify when you have the same x value or the same person more than once. Let's take a look at how we do this graphically now. So let's say you have some points not in a set, but on a graph. So we're going to have something that in a graph we do something what's called a vertical line test. And what we're going to do, and it works the following way. If one vertical line can be drawn that passes through more than one point, the relation is not a function. Now let me add a caveat to this. So it could be 1 point or more than 1 point or more than one line. Now in this case we're looking at points, but we're going to look at lines a little bit here too. So let's say, for example, if I draw a line here, that doesn't mean it's not a function. If I draw a line here, it crosses 1 point, so it could still be a function. However, there's 2 points right here. And as long as I draw a vertical line and have it pass through more than 1 point, we can conclude that this is not a function. That's how the vertical line test works. Now let me tie that into what we were doing earlier. We have the points. I'm going to write down the coordinates of these. This is going to be -4, -3. This is going to be -2, 1 right here, and then -2, -1, and then this is going to be 4, 2. Now the vertical line test catches this in a very quick way, and it's very easy to see. If you look at these as points, like we were looking at earlier, you'll notice that -2, these 2 points where the line goes through, is like one person in 2 different places. So this ties into the work we were doing above. And it's just a graphical way of doing it. But the vertical line test does it very quickly without having to go through all the points and do the people and place comparison. But you see here, it does tie together. The same person in 2 different places at the same time, not possible. Therefore, this is not a function. Let's continue to go through this. Some of these are going to go pretty quick right now. It says use the vertical line test to determine if that's a function. So if I want to try to do that, I want to try to find all I need to do is find one place I can draw a vertical line that's going to cross that line more than once. So I'm going to look at these 2 together. So if I do that here, it seems no matter where I draw a vertical line, it's going to cross this line here exactly once. And without being able to say anything else, based on what I see, I can conclude that yes, that's a function. However, when we're looking at the graph of a circle and want to conclude that's a function, it's very easy in this case to find a place where I can cross that line, the line being a circle in this case, I can cross it 2 times. Therefore, we can conclude in this question that this given graph is not the graph of a function. Okay? In the next 2 questions, you're going to see like y equals 5x plus 2, y equals -2x plus 7. Now, in a graph, you could graph these lines if you want to, but the line's going to have this general trajectory. It's going to be a straight line. The line down here, any line that is the form of y equals mx plus b, where you have an x and a y, and it's straight, this is going to look something like this. Any line like this is straight is absolutely going to be a function. As long as it is a straight line, you will never be able to cross it with a vertical line more than once. That's of the form y equals mx plus b. On the other, let me make sure that everyone can see that. Yeah, you can. Okay. On the other hand, let's take a look at number 9. We have the graph of line y, or x equals -5. Let me see if I can find my graph paper here. I printed out some. Yeah. I'm going to bring some graph paper into the mix here to see how this is done. If I have the graph of x equals -5, it crosses the x-axis at -5, so I'm going to put a line there, cross it right here. Well, if you execute a vertical line test on this line, There's only one line that's going to pass anything on here. It's just going to be the line itself. So if I put a line over that, it's not going to cross 1 point or 2 points. It's going to cross the infinite number of points. So anything that's a vertical line, like this is absolutely not a function. So a horizontal line would also be a function, but a vertical line, like x equals -5 or x equals 3 or x equals -8, never be a function. So just wanted to show that to people here. Okay, let's take a look at the following for number 10. We're getting familiar now and just dabbling just a little bit with what's known as function notation. Where most of you would be seeing y is equal to 2x minus 1. We're going to replace this now with what's known as function notation, where we're going to call this f of x equals 2x plus 1. And where in this case you might have an ordered pair being x and y, we're going to replace that ordered pair with x, and then, let me put a bracket around this, and then this is going to be f of x. I'm just putting a bracket here so I don't confuse the parenthesis I have with f of x with what surrounds this as a coordinate. So what I do in this case here, if I have f of -1, I'm going to write, if I have f of -1, that means in 2x plus 1, I'm going to replace, just like I replaced this x with -1, I'm going to replace this x with -1. Just like I have 0 replaced with x here, or I replace x with 0 here, I'm going to replace x, or 0 with x here. And same thing, if I put 4 in place of x here, I'm going to replace this x from here with 4 here. And I'm going to obtain each of these values. 2 times -1 is -2, minus 1 is -3. 2 times 0 is 0, minus 1, it's going to be -1. 2 times 4 is 8, minus 1 is equal to 7. If I wanted to write these each as pairs, that means when x is -1, f of x is -3. When x is 0, f of x is -1. And then finally, when x is 4, f of x is equal to 7. And those would be my 3 points. We're not asked to do that yet, but we are going to be asked to do that. Okay, that's number 10. Let's go to number 11. We have the function f of x equals x squared plus 2. We're asked to do the same thing we did above. You may want to just try to practice this a little bit and pause the video. Okay, if you didn't pause, we'll keep watching. Otherwise, you can check your work now. Remember to put parentheses with this, because when you square the negative, you want to get a positive result. So that'll be 9 plus 2, which will be 11. 0 squared will be 0, plus 2 is 2. 1 squared is 1 plus 2 will be 3. As an ordered pair, we'd write this as -3, 11. This would be 0, 2. And this would be 1, 3. And those are the ordered pairs. So we have this now looking at 12 and 13. We're asked to do the work. We already kind of started above. It says for the function value f of 8 is equal to -3, the corresponding ordered pair is just going to be the value of x and then the value of f of the final value of 8, and then the function of 8, which is equal to -3. That's it. For g of o is equal to -2 over 5, that's going to be 0, -2 over 5. We're just asking you to kind of rewrite from the work that you're being shown there. Last two questions just touch upon a topic that we're only going to touch on a little bit, but you're going to learn in much more detail in the next couple of math classes that you'll need to take. 14, it says find the domain and range of the function. So when we're looking at domain here, some of this is a little conceptual, so you want to be careful. When we look at the domain, remember, it's all the possible values of x. If we look at this function, for example, you see it kind of goes this way forever, which means it's going both horizontally and vertically up. And because it's going both this way and that way forever, it's going this way, the domain is going to go all the way to positive infinity. The same thing with this line. Even though it's going up, it's also going to the left, which means it's going to the left forever. So the domain we would say is going to go from, actually we're going to do it this way, is going to go from negative infinity to positive infinity. However, the range is not entirely work this way. This goes up to positive infinity, this goes up to positive infinity. The lowest it goes, now watch the scaling here. See how this goes from 0 to 10? That means the scaling is like 2, 4, 6, 8, 10. So this goes up by 2, so watch out for that. So it's going to go up 2 and 4. 4 is the lowest value we achieve for y. Because remember, we want all the possible values of y when we're looking at the range. So for the range of this is going to be 4. We're going to use a bracket because it can be 4, and then it goes to positive infinity because it goes on forever. When we talk about positive infinity and negative infinity, we use what's called a parenthesis, but because it does go down as low as 4, we're going to use a bracket to stop it there. And then finally 15, last question in this section. It asks for the domain and range of this. Well, this goes on from negative infinity to positive infinity upwards and downwards. And we're looking up and down, that's going to be our range. So our range is going to be negative infinity to positive infinity. Domain's a little harder to see on this one. Even though the main direction is both up and down, it is also still, as it's going to the right. Here this is going to the left, and it keeps going in both directions forever. So we can characterize the domain of this as being negative infinity and positive infinity also. And that is going to conclude our work in Chapter 6. Videos for Chapter 7 will be coming soon.